Okay, learning properties of exponents is at first sometimes confusing, and then a bit frustrating, and then a bit liberating, and finally there's a sense of appreciation. So if you're at the frustration stage, I would recommend following the properties in this particular order. So first look for anything raised to the zero power, and then you can apply the power of a power, and then the negative power, then the product of powers, and the quotient of a power. If you go in this particular order, it's systematic. It may be a little more steps, but it's systematic. And we'll take a look at this one example. So the first thing is to look for anything to the zero power, and as you can see, we have b to the 0, so that's going to be 1. When we multiply by 1, it's the identity, so that's gone. The next thing would be a power of a power. So I can have a squared raised to the second power is a to the 4th, and then I have c to the negative 6. And at the bottom, I'm just going to go ahead and copy what I have. So it's negative a squared b to the negative 3 c to the 4th times 2 a to the 4th c to the negative 2. Okay, the next step would be to take care of any negative exponents. So that says we can, if it's in the numerator, we move it down to the denominator, make it positive. So second step, I'm going to keep my a to the 4th. I'm going to make it c to the positive 6 at the bottom. And then in the denominator, I had a negative, I have an a squared. I'm going to make this b to the positive 3rd at the top in the numerator. And I have c to the 4th times 2, a to the 4th, and c to the negative 2. I'm going to move that to the numerator. Okay, now we have all positive exponents. The next step would be applying the product of a power property, which states that if we're multiplying the same base, we simply add the exponents. So we have different bases at the top. I cannot apply it, so I'll just copy down. And at the bottom, I have a 2 and I have a negative, so I'm going to write negative 2. I have a squared times a to the 4th. That would be a to the 6. There's no b's. And then I have c to the 6th times c to the 4th, which is c to the 10th. And then the last step is to apply the quotient of a power rule, which states that if you're dividing the same base, we simply subtract the exponents. So in this case, my numerator, I have a to the 4th divided by a to the 6th. 4 minus 6 is negative 2, so I would write a to the positive 2 in the denominator. I have my negative 2. I have b to the 3rd, and 2 minus 10 is negative 8, so I write positive 8 in the denominator, and it looks like that's my final answer. So it's systematic. We first did the 0 power, and then we took care of any power of a power, then the negative powers, then the product of powers, and then the quotient of powers. And you'll get an answer. If you happen to be in the liberating stage of understanding, I'm going to solve the same problem a different way. And that's kind of the frustration. You can have different solutions and still get the same answer, different approaches to solving and still arrive at the same correct answer. So here we go. We have a to the 2nd squared. It's a to the 4th c to the negative 3 raised to the second. That would be c to the negative 6. So you could write that at the bottom as c to the positive 6. Also in the denominator, we have times negative a squared. B to the negative 3, I could write that at the top as b to the third. I keep the c to the fourth. I keep the 2. I have a to the fourth. And c to the negative 2, I could write that at the top as c to the positive 2. And then continuing, we would have a to the fourth and a to the fourth. Those are going to eliminate. I have 2 and I have a negative, so I would write my negative 2a squared. I have my b cubed at the top, and then c to the 6th times c to the 4th is c to the 10th. So if you have 2 c's at the top, 10 c's at the bottom, we have a total of 8 c's at the bottom. And it's liberating because we can get the same correct answer using less steps. So this is Mr. Martinez. Thank you for watching.